This is section 26, chi-square, in making sense of statistics. Let's do a quick review of nominal data. Now, remember, research data that is nominal, or naming data, which is where you might have participants naming the political candidates for who they plan to vote for. That for nominal data, frequencies and percentages are reported instead of means and standard deviation. Now, this is because the data, the nominal data, does not consist of scores. So it doesn't directly allow the calculation of the means and the standard deviation. So instead of reporting those means and standard deviations for the data, the researchers report the number of participants who named each category, like named each political candidate, and those corresponding percentages. So let's look at an example that illustrates this type of report. So a random sample of 200 registered voters was drawn, and they were asked for which of the two candidates they plan to vote for. And so the data below indicates that a majority of those asked, of those 200 registered voters from a random sample, indicates that a majority plans to vote for candidate Smith. So if you see below, we have an N of 110 and for candidate Smith, and an N of 90 for candidate Doe. Now, when we calculate the percentages of the 200, and you see the 55% for candidate Smith and the 45% for candidate Doe. So while the data suggests that candidate Smith is preferred, let's just remember that this is only a random sample of 200 of the registered voters. So it is possible that the percentage of likely voters is evenly split, that it's 50-50. But the difference of the 10 percentage points, the 55% versus the 45%, is obtained because of sampling error. And of course, now remember, sampling errors are associated with random sampling. And so for this possibility, the null hypothesis then states that there is no true difference in the population, that the population of registered voters is evenly split. So, for example 1, the t-test and the f-test, the ANOVA, cannot be used to test the null hypothesis, because they are tests of differences among means, and so these results are not means. They are number of cases. The N is the number of cases, and the percentages. So when we're talking again, we cannot look at this from being able to calculate a t-test or an f-test because they have to be tested with the difference among means. So let's talk about chi-square and the appropriate test for the data. In example 1, candidate Smith and candidate Doe is chi-square. And a chi-square test is designed to test for differences among frequencies. Now, one of the things is when we are talking about the chi-square test, it is basically saying that the probability that the null hypothesis is a correct hypothesis is greater than 5 in 100. And remember, that is a p value greater than 0.05. So the chi-square for the data indicates the probability that the null hypothesis is a correct hypothesis is greater than 5 in 100. P is greater than 0.05. So the null hypothesis cannot be rejected, and the differences cannot be declared statistically significant. So here again, we're looking at candidate Smith and candidate Doe. Now, example 1 contain data that calls for a one-way chi-square test, which is also called a goodness of fit chi-square test. And this is because the candidates were classified in only one way, which was according to the candidate for whom they planned to vote. Now, this particular example, example 2, what we're doing is looking at data that calls for a two-way chi-square test. And so here again, the participant is classified according to, in this data, whether they are a man or a woman and which candidate they plan to vote for. So as you can see, the random sample of 200 men and a random sample of 200 women were drawn, and they were asked to name the candidate for whom they planned to vote. And the data was obtained, and so when we look at candidate Barnes, and we see that we have 120 men say they're going to vote for candidate Barnes, and 80 women. If we look at candidate Jones, it is the opposite. It is an N of 80. 80 men say they will vote for candidate Jones, and 120 women say that they will vote for candidate Jones. So the data suggests that candidate Jones is a stronger candidate among women, and candidate Barnes is a stronger candidate among men. Now, here again, so this pattern is true. If this pattern is true among all men and women in the population, then both of these candidates need to really be careful, and they need to look at how they can garner more support among the opposite sex of them without alienating the other. So what we would want to say is that candidate Barnes might want to consider ways to increase his support among women without alienating the men, and a similar situation with candidate Jones, where candidate Jones might want to increase her support among men without alienating the women. Now, what we are saying though, also let's look at the chi-square for the data. So indicates the probability that the null hypothesis is correct is less than 1 in 1,000. So it's a p-value of less than 0.001. So it is unlikely the pattern of difference is due to sampling error, and the null hypothesis is rejected. Now let's again look at example 3. So in example 3, a random sample of college students were asked whether they think the IQ test measures innate or inborn intelligence, and whether they had taken a course in psychological testing. And so here is the result of the data. Now, when we have a chi-square, what we see within the chi-square is that we have a p-value of less than 0.001. Well, what this means is that we reject the null hypothesis with a high degree of confidence. The odds are less than 1 in 1,000 that the null hypothesis is a correct hypothesis. And remember now, the null hypothesis says there is no true relationship in the population. Let's look at example 4. In example 4, what we are looking at is how chi-square is written in a journal. So sometimes when we're talking about writing statements, this is what we're talking about, is writing a statement for a research report for the journal. When you write chi-square in a journal, you want to make sure that you address whether the relationship is statistically significant, and you also want to talk about the relationship and the direction of the relationship. So this states the relationship was statistically significant, with those who took a course in psychological testing being less likely to believe that IQ tests measure innate intelligence than those who did not take the course. And then we report the outcome of the chi-square. We report the degrees of freedom, and we report the p-value. And this concludes section 26, chi-square. Our next section is section 27, which deals with the limitations of significance testing. Please be sure to go back and read your text in chi-square. It is not difficult to understand, but it is important that you continue to read your text along with the videos.